So this is going to continue what we were just talking about with energy is equal to Planck's constant times frequency. So I'm going to work a couple calculations with you. Again, have a calculator out for this video. Pause it, try the calculations yourself, and then check them with my calculations. Again, the more you do these calculations, the easier they will come. So again, I will always give you Planck's constant. You will have to memorize this equation. And what I'm going to give you is either energy or frequency, and you're going to have to do the calculation. So I'm going to switch to another piece of paper here that has it written out a little bit more. But again, pause the video as you can and try the calculation. So if I give you the energy, what is going to be the frequency? So again, if I have energy and I'm trying to find frequency, I'm going to have to use the Planck's constant. So I have energy over here is 9.82 times 10 to the negative 22nd. There is my Planck's constant, and that is my frequency. So what I have to do to get the frequency by itself is divide 9.82 times 10 to the negative 22nd by the Planck's constant. So again, using your calculators, type in 9.82, hit the second function key, and you should see E pop up in your screen. And we're going to do a negative 22. Then divide it by the Planck's constant, which is going to be 6.626. Second function E, and you're going to do negative 34, and you're going to hit the enter button. And my calculator is already in scientific notation, so it's 1.48 times 10 to the 12 times 10 to the 12. And that's going to be, again, my frequency. That's going to be hertz. And again, if you want to do F for frequency, go for it, okay? So again, you're always going to be essentially using Planck's constant and dividing it in there. If I give you frequency, you're going to take frequency times Planck's constant to get the energy. That's the easier calculation, okay? So looking at this next one, what I'm asking you to do is go a next step. So you're going to require both equations that I've showed you. And I do want you to go all the way to nanometers. So if you could do this calculation, you could do any calculation I'm about to give you. So here's my energy. I want to go to frequency. So again, it's exactly like the previous problem, okay? So you're going to take your energy and your Planck's constant, you're going to take your energy and divided the Planck's constant into it to get the frequency by itself. So you should end up with 5.25 times 10 to the 15th hertz. So that's going to be your frequency, and that is the first step to the problem. But you're not done, because I have to go all the way to wavelength, and I do want you to go all the way to nanometers. So you're going to have to use the other equation that I taught you using the speed of light. So I have to find my wavelength. So speed of light divided by my frequency is going to give me my wavelength. So again, this equation you're always dividing into the speed of light. So I'm going to take 3 times 10 to the 8th and divide it by the hertz that I got up here, my frequency, my inverse seconds again, and I'm going to get my wavelength. So when I do this calculation, realize my wavelength is going to be in meters. So I get 5.71 times 10 to the negative 8th meter. But I want to get it into nanometers. So I'm going to multiply it by 1 times 10 to the 9th over 1 meter. So again, you're usually just moving the decimal over. Since this is 10 to the 9th and this is 10 to the negative 8th, you end up with 10 to the 1st. So I'm going to take 5.71 and multiply it by 10. I get 57.1 nanometers, okay? So that's going to be an easy calculation, or it's going to get easier if those numbers are very close. So again, look at those powers of 10, and that will help you out. All right, so one more calculation here that I did has to do with, I'm giving you the energy, and I want you to again go all the way to wavelength, go all the way to wavelength. And again, the wavelength, I want it all the way to nanometers, all the way to nanometers, okay? So pause the video, see if you could do the calculation, then pick up the video and see if you get the same answer. All right, so first step is to find my frequency. First step is to find my frequency. So I'm going to take my 6.92 times 10 to the 19th and divide Planck's constant into it to get my frequency. So I get 1.04 times 10 to the 15th hertz, okay? That's going to be how I get my frequency. But I'm not done because I have to go all the way to wavelength, and I need another equation for that, okay? Because again, this equation is energy is equal to Planck's constant times frequency. I need the second equation for this next one. So wavelength is equal to speed of light divided by frequency. So I'm going to take 3 times the 10 to the 8th and divide it by 1.04 times 10 to the 15th, which is my frequency. And I'm going to end up with my wavelength. Well, I end up with 2.88 times 10 to the negative 7th meter. And I have to convert that to nanometers. So I'm going to multiply it by 1 times 10 to the negative 9th. And I get 288 nanometers. Again, 9 and a minus 7 ends up with 10 to the second. That means you're multiplying 2.88 by 100, you get 288 nanometers. Again, and this could all done with your calculator. All right, so the last problem I have on your worksheet is going backwards from these, okay? So I have 382 nanometers, and I have to go all the way to energy. Well, please note with all of these calculations, you can't do anything with nanometers. You must convert it to meters first, and then you could do the rest of the calculation as is. So again, start with 382 nanometers. I'm going to pause here, see if you could try it, and see if you could go all the way to energy. All right, so first step is to convert nanometers to meters. Again, I'm going to take 10 to the 9th, but this time I'm going to divide it by this. So essentially what I'm doing is moving that decimal 2 over and then another 6 zeros, 7 zeros, 6 zeros. So I get 3.82 times 10 to the negative 7th meter. Okay, and again, doing this in your calculator, you could take 382 and divide it by, hit the second function key, and hit that double E function. Oops, not yet. Hold it, hold it. I gotta type in a 1 first, otherwise it will get confused. Hit the second function key, and then hit that double E function. Okay, so that should be what your screen looks like, and type in a 9, and then it should spit out 3.82 times 10 to the negative 7th meter, okay? All right, so once you have meters, you're good to go, okay? So now you're gonna take the speed of light, divide the speed of light by that 3.82 times 10 to the negative 7th, and you're gonna get a frequency, 7.85 times 10 to the 14th. Again, hertz, or you could do 1 over seconds, it does not matter, all interchangeable. Well, this is the easier of the two because all you got to do is now take that frequency and multiply it by Planck's constant. So Planck's constant is 6.626 times 10 to the negative 34th. Multiply it with what you got on the frequency, and you're going to end up with the joule. Okay, so again, the unit here is due to, this is joule seconds, and this is inverse seconds. So when you multiply them, you're ending up with joule. You're ending up with a joule. So again, try these calculations, see how they go. I will give you extra practice as well, but these are going to be the calculations we focus on for light.